This video is on the objective compute the value of the test statistic using the expected frequencies for a chi-square independence test. And this is the second video on this. I'm hoping you watched the first one. It was pretty long. Got you an introduction to this, calculation of the test statistic and also the calculation of the expected frequencies for each cell of the contingency table. So here I'm just going to straight up go to the calculator. All right, and remind you how to do that real quick. All right, so again, if you want to see more about it, click on more instruction, look at their videos, their notes, their examples, and hopefully those help. All right, so here a bill is brought to a group of politicians, Democrats and Republicans. Researchers recorded the expected values and then polled the group on whether they would vote in favor, opposed, or indifferent. These values are recorded in the contingency table below. Which of the following tables correctly shows the expected values for the chi-square independence test? So remember, for each cell, now there are two rows here. Remember, the total rows don't really count. These are kind of extra. They help you calculate the expected values, but they're not part of the actual table. You have the Republicans and how many would say vote in favor, would be indifferent, would vote opposed. You have the Democrats, how many would vote in favor, indifferent, or opposed, right? So this is 2 rows, 3 columns that are important to us with the observed counts. So when I go to my calculator, I'm going to make a 2 by 3 matrix. And now recall that the expected values for each cell, how many would you expect to be a Republican and in favor? You take that row total, multiply by that column total, and then divide that product by the grand total. Right? There are a total of 97 senators here, politicians, in this table. So for the expected value of this first row, first column, the Republicans in favor, I'd take 50 times 31. All right, 50 times 31, that would be 1550, and then divide by 97. So almost a little under 15.5. Well, no, a little more than 15.5. So I'm going to say this one here. Okay, because that's 16, and we got 15 and 14. I'm gonna say this one here. Well, let's see. All right. Now you could do that in a calculator. Now you gotta do that for every single one. And they're asking you. Now notice, really, you only need to do it for the first one, first row, first column, because all the first row, first column expected values in bold are different. So like I said, I believe it's going to be this one. Now, if you want to do this really quickly on your calculator, find all these expected frequencies for each cell in my table. Well, let me bring up the calculator, and like I said, this is 2 rows for the politician, the party, and 3 columns for how they'd vote. And we're determining, if we were to run an independence test, we'd be trying to determine if the political party and how they vote are independent, or do they have some sort of relationship. Right. Well, I'm going to enter a 2 by 3 matrix, right? So remember, the matrix menu is above this x to the -1 or x inverse button. Go matrix, and then I'm going to go make a matrix. Go over to edit, and then matrix A, say. And it's 2 rows by 3 columns, right? That's what the upper row gives us here. 2 rows by 3 columns, and you see these 6 entries I got to enter. Well, I'm just going to enter the observed entries from my table. The first row, first column are the Republicans in favor of the bill, which were 10. First row, second column were Republicans indifferent to the bill, which were 16. And the first row, third column were the Republicans opposed to the bill, which was 24. And then the second row, first column were the Democrats in favor, 21. Then Democrats indifferent to the bill, 5. Then Democrats opposed, also 21. All right, then get out of here. Just go second quit. And then if you want to see all the expected counts, just perform and just run the chi-squared test on the calculator. So I hit the stat button, go over to tests, and then scroll down to, I believe it's C, where it first says chi-squared test, right there. And then it'll ask you, what are your observed counts? Well, you're going to enter a matrix here. So I go second to the matrix. Now it's already matrix A. So, and then under names, I just enter matrix A. But matrix A was already there. I really didn't need to do anything. And then for the expected counts, well, we didn't enter a matrix for expected counts, but we don't have to. If you entered your observed counts correctly, the expected counts will be calculated for us automatically. So just make sure that that's a different matrix. So matrix B. And then just go calculate. Now see, it already gives me the test statistic, right, which is what's going to be the question after this part of the question. And the p-value of the test, the degrees of freedom, but we're focused on the test statistic right now. Let's get out of here, quit. And after you've run that test, if you go back to the matrix menu, you see there's a matrix B now. That's another 2 by 3. 2 rows, 3 columns. This will be your expected matrix. If I enter matrix B on my screen here, see the first one is 15.979. That would round up to 16. See, I notice they're rounding to 1 decimal place for all these. So for the first row, first column, the expected count, the expected frequency would be 16. For the second row, first column, this would be 15. Then the next, then let me go back to the beginning here. Scroll back and forth. All right, so back here. All right, so I have 16, 15, and then you're seeing 10.8, 10.1, well, 10.2. And then for the third column, oh, that looks like that is the last column. Oh, yeah, for the third column, 23 point, keep scrolling, 23.2 and 21.8. So here, that was this last one, see? 23.2, 21.8 for the expected outcome, the expected frequencies in the last column, 10.8, 10.2, 16, 15. So like I said, like I suspected in the beginning, it's going to be that last one, that last option. All right. And then they're going to ask you for, and they show you there, then they're going to ask you for, okay, now what is the test statistic? And it's a multiple choice one again here. I forget what it was already. So I'm just going to go back to that test, stat, tests, C, right, and calculate the chi-squared test. Yeah, it was 9.78. Now, that would round to 9.8. The closest one here is 9.9. So I'm going to select that one. Now the reason why our calculator is a little off from what they have is because of the rounding, right? They rounded all these values, these expected values, to 1 decimal place, and then rounded the final answer to 1 decimal place. So lots of rounding going on there throughout the calculation. So their final answer may be a little off from the calculators, because the calculator is actually more accurate. Right? I like the calculator answer better, 9.8. But the closest one here, 9.9. And again, when you look at the answer explanation, you see that they're using those values, those expected counts that are rounded to 1 decimal place, right, when they're calculating the test statistic. All right. So again, hopefully the calculator will speed things up a bit for you. Just be careful. If there are some, and you may have seen this you'll see this in another video of mine. There are some where they have you enter the test statistic rounded to 1 decimal place. If that's the case, try what the calculator says, and if it says it's wrong, then you're probably going to have to bump it up or down 1. So if it says it's wrong, that means that the rounding had an effect. Sometimes the rounding won't have much of an effect. Sometimes the answer you get in the calculator will round to the same 1 decimal place that the answer they're given does. Sometimes those will be the same. But again, if it's not, if it says you're wrong, then you're going to have to go in and use those values and calculate it kind of in a longer way. But it'll just be like seriously 1 decimal place off. Like it'll be really close. So just be careful. Right. Well, hopefully you can use the calculator as a guide, as a little speed, and you can definitely you saw you can use it as a very speedy way to find all those expected counts. All right. All right. So hopefully watching me do this on the calculator here, looking at the more instruction if you need to, reading the answer explanations when they come up. I'm hoping all this stuff helps you out when you're working on this material on your own. And thanks for watching.